Hello everyone, and welcome back to Everything Anything Computing. This is lesson 7 of our Learn and Read Development with Kotlin series. Today, we're going to dive into one of the most important building blocks in programming, functions. By the end of this lesson, you'll be able to write and use functions in Kotlin, work with parameter and return types, understand that almost everything in Kotlin has a value, create compact single expression functions, use Lambda expressions and high-order functions, filter and transform lists in a clean functional way. And as always, we'll be tying all this into our tenant management system example to explain the different concepts. So let's get started. What are functions? In Kotlin, a function is like a reusable instruction. Instead of repeating the same steps again and again, we write them once and give them a name. Whenever we need those steps, we just call that name. Yeah? So think of it like a landlord having a standard letter for let rent. They don't write it from scratch every time. They use a reusable template. So every time we have a tenant who's let to paying rent, we just take that template and change a couple of few things like the name and so on and so forth. So before we see how these functions can be reused, or these functions are used in Kotlin, we need to know how to write them. And as I mentioned, Kotlin is a language. So because Kotlin is a language, we need to understand what are the different keywords our compiler will pick to know that whatever is written here is a function. Yeah? And what are the best syntaxes so that every time I actually write it, the compiler knows that this is a function and it is written in the right way. So let's do everything practically. But before we get into what we're doing today, which is functions, just a quick recap of what we did in our previous lesson. If you haven't checked that out, it is in the link in the description box. I've also attached it on the video, just right at the top right of this video. You can click on it and see. So last week we did something to do with conditional statements, where we looked into if and else. We also looked into when. And then we went to the second section of our class where we did list and arrays. And then finally, we did null safety, which is basically avoiding crashes within our system because of values or memory allocation of variables that are actually null or empty. So today we're going to get into functions. So let's just start. So the first things first, we need to know the keyword. And the keyword for function is fun. So once your compiler sees fun, they know that fun is a function. So in this case, it will be fun, and then we give it a name. And our name in this case is, we could say, send tenant rate reminder. So we have the keyword fun that tells us that this is a function. And then we have the name of the function. And if you see clearly right now, we have it highlighted in red, meaning there's something we're still missing while writing this function. And then we have an opening and closing brackets. So that's the what follows when you're writing a function. So you have the keyword fun, we have the name of the function, we have the opening and closing brackets, and you will see why this is important when we get to parameters. And then finally, we have the open and closing curly braces. And you can see now, we no longer have the red highlight, because then it means we have followed the right syntax. Our compiler that knows that through the keyword, this is a function, and this is the name of the function, and the syntax is correct because we have the opening and closing brackets, and we also have the opening and closing curly braces. So now when actually writing the actual instructions, we write them within the opening and closing curly braces. So everything within this opening and closing curly braces tells the compiler that these are the instructions of my function. And in this case, we just want an instruction that prints a line that says, please pay your rent. So print, and we said to do that, we have a keyword print line, open and close, write the double quotation, and we say, hello, Salome, you are late in paying rent. Please clear. So now, So first now, this is our actual function, yeah? This is the function that actually prints a line that says this and this and this. And the reason as to why it has not appeared here yet is because we haven't called that function. And I told you that because it's a reusable instruction, you have to call it for a specific context for it to work. So in this case, we can create a variable. And that variable is called rent reminder. And then it's equal to, or we can say tenant one rent reminder. And then we initialize it to send rent reminder. So we've initialized it to this function. So now when we say print line, call the variable now tenant one reminder. So now when we actually run this, we will see, hello Salome, you are late in paying your rent. Please clear. So this is how we call our function. So what now we are going to look into? We're going to look into something called working with parameters and return values. Okay, so let's just have that there. So working with parameters and return values, what is that about? So we've said functions are instructions. And sometimes with instructions, we might want to have input values. Think about it in terms of the letter I was talking about when you're writing a letter to your tenants. Not every tenant has the same name and not every tenant lives in the same room. Yeah. So every time you're using this template, you'll have to change the name of the tenant and you'll also have to change the room of the tenant. Yeah. So you could say, Dear Odhiambo, you are lent. Thank you for being a tenant of us of room this and this and this. However, you are late in paying your rent of this amount. So not every tenant has the same amount. So of this amount and so on and so forth. So in this case, you can have a return value. So here, first we have a function that sends a tenant reminder. And the function basically says, print, hello Salome, you are late in paying rent. However, we can include another function that actually calculates the amount of fee that is late. So we have a function and we say calculate late fee. Open and close. So because it's open and close, we know that here, this is the idea of where parameters come in. So inside here, we can write the inputs that we want. And the input that we may want is first, monthly charge. And then it returns an int. Yeah. So that's the first parameter it takes, or the first input. You can think about it as the first input value my function takes. And then you can also think about the rate. Rate, that is daily rate. Let's just think about it. Rate of payment. When I talk about the rate of payment is at what rate does the person usually pay the rent? Is it after every month? Is it daily? And so on and so forth. And then this returns an integer as well. Okay, so clearly we still have our syntax wrong because we are still highlighted red. So we can have another thing here. So this is another thing, introduction that I'm introducing, which is it's a return value. And what you're saying is, once everything has been calculated, the value that will be returned should be a double. So everything outside the opening and closing bracket, it usually symbolizes what type of value is being returned by the whole function. And that type of value here is a double. And then finally, let's open and close. And you can see clearly that we still have a red because we are telling this function is going to return something. And inside the function itself, the instruction itself, there is nothing that has been written. So what we want here to do is we want it to return This is the keyword. So this keyword allows us to return a value or a calculation of what is our function returning. So return monthly charge times rate of payment. We can change this to a double. That's why we were having a problem. Okay, so now we see we can return a monthly charge times rate of payment. And the reason as to why it was highlighted, because normally we cannot, if every type here was an integer and an integer, we cannot give it a double. Then it will mean we are changing the data type. Okay, and then we can calculate. We can create a variable, and that variable basically is default amount is equals to, we call our function, which is this. And inside the function, we actually now put the input. And our monthly payment is, let's say, 500. Yeah, so that's the monthly charge, and you can see it auto-completes for you. And then the rate of payment, let's say, is 2 days. So that's the rate of our payment. So 2.0 if you think about it. Okay, so that's our rate of payment, 2.0. So now we can actually call this default amount, hello Salome, in this sending tenant reminder. And then we can use something called the string interpolation, which is basically, we haven't covered strings clearly, so we will learn about that in our later. So here now, when we call this function, what it will do is the function will call this function here. So when you call this function, it will print this function. It will call this function that calls this function. So let me just show you how that works. So now when we run, we can clearly see here, hello Salome, you are late in paying your rent. Please clear 1,000 shillings. So now you see how everything works. Or you can just print it here and print, or just call it here. So default amount. Sorry. You can call it here. Calculate. Print. Line. The default amount is default amount. So when you run this, it will have 2. So the default amount is 1,000, and you also have the idea, I just misspelled this, so you can change that. Or you can have the idea of, hello Salome, you are late in paying rent, please clear 1,000 shilling. So you see the whole idea of writing your functions, how to call them, why you need them. So now if you need to send a tenant reminder, all you need to do is call this, which calls this. And it makes it easier for you. Every time you need, all you need to do is maybe here on the value that default amount just changes the monthly charge and the rate payment, and everything is easy for you. So that's the first things we were doing, which is working with parameters. So now we can go to the third thing. Understanding that almost everything in Kotlin has a value. What does that mean? So sometimes when you're writing your expressions, you think that the expression itself does not have a value, but that is not true. Let's just take a simple example like an if-else statement. And in this if-else statement, we have if 7 is greater than 0, then return 8, else 5. So in this case, we have a simple expression that says if 7 is greater than 0, return 8, else 5. And you think that this doesn't hold a value. But let me show you that it holds a value, because sometimes you think that you have to every expression in Kotlin has a value. So let me just initialize a variable to this. So what we're doing is here, we're giving it a memory allocation. So variable amount will be equal to, and then let's print amount. You can see that this expression actually holds a value. All you need to do within an expression is give it a memory allocation, and you will always see the value of that expression. So that's the whole point of every expression in Kotlin holds a value. Provided it's an expression here, and then you give it a memory allocation, you will see what value is within it. Okay, so we're going to look at something called the compact or single expression functions. So what basically this means is you do not need to use the opening and closing brackets. You can have a function as an expression. So this is how we write an expression, create a compact single expression. And this is the reason as to why we understood the idea of every expression has a value is to know that when we are writing a function, it can be an expression and it can hold a value. So how to do it is a function fee, and inside the fee we have 20. It returns a fee. Actually not a fee. Fee charge. It returns a fee charge, which is equals to fee charge times 3. Let's say that. Yeah, so we have a function fee that returns a fee charge, which is a double. So now this expression actually returns a value. So when you're calling it, you're going to call it in terms of print line, and then fee inside put the amount, which is 50.0. And then when you run this, it takes the value, which is the fee charge itself, and then it multiplies it by 3, the fee charge by 3, and when you return it, it returns the value of the fee charge. So you can see what actually creating a compact or single expression fee. So you just write it as it is without having an opening and closing brackets. You just have the name of the function, inside you have the parameter, and then now you just initialize it to the actual instruction you want it to do. And then we can go to using Lambda or high order functions. So this basically what it means is we are going to use a function as a parameter inside another function. So let me show you what that means. We can have such a function, and this function basically processes fee. And this function returns a value or a value of double, and inside it we have another function, and this function is an operation, and that function takes up a value of double and returns a double, and the whole function returns a double. So the whole original function, which is process fee, returns a double. So we have operation function here, and we have process function. So process functions returns a fee, which is a value that returns a double, and it also returns a function that returns a double as its value, and then finally the whole function returns a double. So inside, when you do a return type, you can take the function that it was returning, and then you put the fee, which is this, and then once you're calling it, which is a value that is discounted, is equals to process fee, it takes the fee, which is this, and when trying to make it now as an expression, you open and close your brackets and say it. So this keyword it, basically, it says whatever was within the process fee, multiply it by 0.9. Whatever function was within the process fee, multiply it by 0.9. And in this case, we take the print line and discount it. So when you run it, you have 180. So it takes a variable. The variable calls the main function, which is process fee. Inside it, it returns a value called fee. And then when you open and you're closing your bracket, it takes now the other function, which is operation. And the operation usually takes the fee. You multiply it by 0.9, and then you print the discounted, and it will return the whole thing. So that's the whole idea of having an exception within an expression. And then finally, we have filter and transform list in a clean and functional way. Okay, so you can use function to filter list. And when we were talking about list last time, we said that list can take, so let's say we have variable tenant amount is equals to list of, we don't want to, so that opening and closing, the greater and lesser sign usually allows you to write the type of data of the list. But this one we already know it's going to be a double, 500.10, and then 500. So we can use function to transform this. And by transforming, we mean that we can use it to filter. Maybe you want to filter any tenant who has an amount less than 200, tell him this. Or any tenant who is greater than 200, multiply it by this. So you can use filter, or you can use a function called filter, or you can use a map. A map will allow you to map every individual value within the list and map it with something. So another thing we could use was the add. Last time we used add, and add basically allows you to add a value within your actual list. So this is just an inclusion of other functions you can use with lists of, arrays of, and so on and so forth. So in this time, we're just transforming. And transforming, you're not changing anything, because you remember list of, you cannot change anything within that list. You can only transform it. And transforming is, you leave it as is, but maybe filter it or multiply it by something. So here in this case, we have a variable called tenant, and then we want it to filter. So tenant, yeah. So now if it is less than 200, so you can, it will print values that are less than 200. We can have another one that multiplies it by something. So using map, multiply is equals to, and then tenant amount dot map, then open and closing, sorry, not open and closing, but that, and then it, and then multiply it to 100. So basically here it will map every value within this list into multiplied by 100. So when we actually run this, so print line, we can have this, the amounts less than 100 equals to, then $, amount less than 100, and then those who need to upgrade will be equal to $, multiply. So this idea is, maybe you have, you want to check all the amounts that are less than 500 and what they are. And then maybe at the end of the time, you can even have those amounts and then you map them and multiply them. You have a function that multiply each amount. So for every amount within my list, multiply it that is less than 200, multiply it by 100, and so on and so forth. So when you run this, you'll see that the amount less than 100 is this, and the ones who need to upgrade is this. So here we is empty because there is no amount less than 200. And then those who need to upgrade is this, because there's amount that is actually, you can multiply each amount by 1000. So that's the whole idea behind functions. And just to repeat what the it keyword does, especially when we're using the high lambda function, maybe I didn't explain it very well. But the it basically here, when you're talking about the it keyword, the it keyword calls the actual function. Yeah. And what are the parameters within that actual function? That's what is actually called. In this case, we are talking about that it, and then we are multiplying it by 9, 0.9, and so on and so forth. So you can call an operation, and that operation actually returns a fee. So it's telling you just call that operation and multiply it by 9. So I hope that makes sense. Thank you so much for joining me in this class, and I'll see you in the next class where we'll be talking about classes and objects.